defined by one single word: possibilities. Possibilities.
To us, of any of them that aren't in our own solar system, Proxima b
is a galaxy cluster halfway to the edge of the universe.
Something strange has been unfolding in the solar system closest to our own. Proxima Centauri is only 4 light-years away, and scientists have detected strange signals emanating from one of its planets, Proxima b. What are these mysterious irregularities, termed artificial lights, that have baffled the finest minds in the space community? And may this indicate the existence of intelligent life on the planet? The enigmatic light spotted by the extraordinarily powerful telescope in one of the photographs may be the proof we need to determine that another planet in the universe may contain indications of life. Today, we will examine the information provided by the James Webb Space Telescope and its actual meaning. One of the major goals of the James Webb Space Telescope is to seek out habitable exoplanets, where one day we may be able to find evidence of intelligent alien life. However, habitability is not a simple matter, and detecting another Earth-like planet may be more difficult than you think. Around 40 light-years away lies a remarkable star system. 5 years ago, the TRAPPIST-1 system shot to fame when NASA and its partners announced the discovery of a number of Earth-sized planets in the habitable zone of a single star. Since then, scientists have been frantic to uncover all information they can about these close planets that might be similar to Earth. Scientists at NASA had no idea what they were getting themselves into when they launched the cutting-edge James Webb Space Telescope from the Guyana Space Center on December 25, 2021. Astronomers expected to detect signs of life in the atmosphere of distant planets and galaxies, but had no idea that the first photographs from the JWST would alter how we interpret space. James Webb has 2 infrared cameras. The first is the near-infrared camera, or NIRCam, which is capable of capturing the shorter infrared wavelengths. Second, the MIRICam, or mid-infrared instrument, is what you need to see at those longer infrared wavelengths. The photographs differ based on the camera used to capture them. NASA has provided us with numerous photographs obtained by this large one-of-a-kind telescope, and these images are, to say the least, stunning. But if the initial photographs have shown so much, what might the next James Webb data reveal, and is it all good news? The information acquired thus far appears relatively harmless, but you never know when the tide will turn. In the end, NASA hopes that this telescope will be able to pierce dust clouds and detect light from the farthest reaches of the cosmos, a realm that could be both frightening and thrilling. The most remarkable aspect of the JWST data is not an image, but rather spectrographic data about the planet WASP-96b. This exoplanet is located around 1,150 light-years from Earth. Any planet beyond our solar system is termed an exoplanet. James Webb is also equipped with a near-infrared imager and slitless spectrograph, or NIRISS, in addition to NIRCam and MIRICam. The NIRISS instrument placed on the JWST, which measures the intensity of various light wavelengths, measured the light emanating from a WASP-96b for around 6.5 hours and plotted the resulting data. Based on these findings, there may be water on this planet. This mostly gaseous planet has roughly half the mass of Jupiter and circles its sun so closely that 1 year on this planet is comparable to only 3 to 4 Earth days. Astronomers have learned a great deal about how molecules on this planet absorb and re-emit light from its host star because of the planet's short orbital period. Separating this spectrum of light into its component wavelengths allowed scientists to determine the composition and abundance of the planet's atmosphere. By analysing this information, scientists have come to the conclusion that WASP-96b has water. In fact, this planet's atmosphere contains a significant amount of water vapour. Despite the optimism this image has given us, the temperature on WASP-96b is about 530 degrees Celsius, making it extremely hot to support any type of life. However, in the next months, the telescope will be directed onto a new planet and take images of it. This one is thought to be possibly habitable, but let's not go too far ahead of ourselves. Scientists hope they can utilize spectrum photographs of many other planets, including those outside our solar system and galaxy, to advance their hunt for indications of life in the universe's furthest reaches. The second image this magnificent telescope revealed is of the Southern Ring Nebula. This nebula is also known as the 8-burst nebula because of the 8-shaped cloud of dust and gas spewed by this enormous dying star. It is around 2,500 light-years from Earth. A spectacular orange froth of molecular hydrogen can be observed whirling over a bluish haze of ionized gas. The dying star at the image's center is responsible for expelling all of this material. Mid-infrared imaging of the same nebula reveals a second red star shining close to the brilliant blue one. Now, scientists have known for a long time that the Southern Ring Nebula is a binary system. But this is the first time the second star has been so vividly imaged within the dense cloud of dust. A large number of galaxies are readily visible in the background of this view, as they are in all of JWST's photographs. This suggests that there are many mysteries left to be solved. Examining this image more closely, experts spotted a faint line in the upper left part. Carl Gordon, a NASA astronomer, initially believed it to be part of a nebula, but after observing it with 2 infrared cameras, he recognized it was a side view of a galaxy. So the mysterious, inexplicable light seen by the JWST was really a complete galaxy that we may have missed. There is a possibility that the dust particles ejected into space by the dying star may condense to become the seeds of future stars and planets. Additional study of this nebula might help scientists comprehend the processes of star death and rebirth. Another primary target of the James Webb Space Telescope is a cluster of 5 galaxies around 290 million light-years distant. This collection of galaxies is known as Stephan's Quintet and is found in the constellation Pegasus. According to NASA, 4 of these extremely near galaxies are regularly passing at a dangerously close distance, putting them in danger of colliding. The extraordinarily high-resolution image indicates that 2 of the 5 galaxies are in the process of merging. The leftmost of these 5 galaxies is approximately 40 million light-years closer to our solar system than the others, hence the picture of this galaxy has a better resolution. Scientists believe they may learn about the behavior of gravity at the biggest scales by studying galaxy clusters like this one. This can also help them understand more about the enigmatic, unseen, and huge substance known as dark matter, which is believed to be the substance that holds the universe together. Before any of the other photographs taken by the James Webb Telescope swept the internet, on July 11, 2022, we were given a peek of the universe's deepest image. This is a picture of the galaxy cluster designated as SMACS 0723. This incredibly high-resolution, high-definition image shows the most detailed glimpse of the breathtaking cosmos of which we are a mere part. This picture shows the light that was released 13.5 billion years ago. This is close to the estimated age of the universe's inception, 13.8 billion years ago. James Webb Satellite Telescope's capacity to tap into the gravity of galaxy clusters is on full display in this deep field image. It then amplifies the distant galaxies behind these clusters, providing astronomers with a very sharp perspective. The SMACS 0723 cluster is located around 5 billion light-years from Earth. These high-resolution color images are the result of a 20-year effort by NASA to launch a groundbreaking new space observatory to replace the legendary Hubble Space Telescope. The James Webb Space Telescope, which is 100 times more powerful than Hubble, has been entirely reserved for its first year of scientific operations. Using the data gathered by this telescope, scientists are expecting to make groundbreaking discoveries, whether it's black holes, cosmic expansion, or even the earliest births of stars. Owing to this incredible technology, science is on the cusp of investigating unfathomable possibilities on all fronts. However, is it possible for the JWST to find aliens by looking at their city lights? Scientists have been confused by this question for years. As far as we can tell, the cosmos should be filled with many species. Moreover, many of these aliens should be technologically adept enough for us to communicate with them, or at least pick up their radio transmissions. We have not yet seen or heard anything, and the sky appears to be without life. Recent research, however, discovered something. Maybe we are looking in the wrong place. Instead of listening to extraterrestrial radio transmissions, we should attempt to see their city lights. However, from light years away, how can humans see these faint lights? Is this quest even worthwhile? Now that the James Webb Space Telescope is operational, we have access to entirely new technologies for astronomical observation. This telescope is sufficiently powerful that it can actually view and image exoplanets, as opposed to merely inferring their existence like virtually every other telescope before it. Long before JWST was operational, Avi Loeb determined how the telescope could utilize this capability to observe extraterrestrial cities. He based his calculations on Proxima b, the closest exoplanet similar to Earth. We can observe both the day and night sides of the exoplanet by observing it at different orbital positions. We may then compare the actual brightness to our predictions, and if there is a variation, we can attribute it to an extraterrestrial civilization's artificial light. The James Webb Space Telescope will also explore the TRAPPIST-1 system during its initial cycle of research projects. The goal of the research is to determine if the planets in the TRAPPIST-1 system have atmospheres and, in the long run, to establish a method for searching biosignatures that might indicate the presence of life on any of the planets. However, there are several obstacles when it comes to understanding planets that are distinct from our own. Recent theoretical work demonstrates that a planet's distance from its star and composition are not the only factors that influence its environment. The distribution of land throughout a planet's surface also has a substantial impact on its potential habitability. James Webb will begin studying the TRAPPIST-1 system in its first year of science, and it will be tremendously exciting to receive additional information about these exoplanets. Finding a habitable planet from billions of light years distant will be difficult, so don't start planning your relocation to Earth 2 just yet. Let's hear your thoughts on the likelihood of the JWST discovering a habitable exoplanet in the coming months.